All right, solving trigonometric equation involving factoring part 2. So this is the case where you don't see a straightforward application of substitution as shown in the previous video. So you're going to have to look at the four terms that you have. Really, you have four terms, 1, 2, 3, 4, and see if we can group them somehow. So in the end, you're going to end up with factored statement. So what are we going to do? We will find the following factor. 5 sine x will combine the first two terms. So let's do that. So 5 sine x goes out. And I have from the first term 5 cos x minus 1. Okay. And just imagine 4 becomes part of the left side. So 4 can be factored out, and you're going to have 4, and we'll have 5 cos x minus 1 equals to 0. Okay. Now you may ask questions. Why do I have positive 4 on that side? Since you bring 4 from the right hand side, you expect to change its sign. But indeed I have negative 4 if you were to distribute it. 4 times negative 1 will give me negative 4, and 4 times 5 will give me 20. So what I see now that 5 cosine x minus 1 becomes a common factor now for this binomial. So let's take it out. 5 cos x minus 1 as one factor. In goes 5 sine x plus 4. There we go. This is quite amazing, I must say. So this is equal to 0. So this format of the given equation is very convenient because we have two terms where the product is equal to 0. So this simply means that the first one must be 0 or the second component must be 0. So let's go for that. So let's say 5 cos x minus 1 is equal to 0, or 5 sine x plus 4 is equal to 0. Further down, we'll have to isolate cos x from that equation and sine x from the second. So let's do that. So cos x is equal to 1 over 5, or sine x is equal to negative 4 over 5. Wow. So I have solutions to both equations. In the past videos we were ending up with one component with solution, the other factor no solutions, but in this case we have two. So again, no particular exact value is going to be applied here, so we have to use our calculators. So x, just remember, cosine x is positive first and last quadrant. So x will be cos inverse of that ratio 1 over 5. Maybe I should quickly recall cosine wave. So we're going to see the following. I have this beautiful wave from 0 to 2 pi. and cosine x is equal to 1 over 5. So remember this horizontal line that intersects. So I have two answers here. So the first quadrant before you hit pi over 2, and the last one after you hit 3 over 2 pi. So your calculator will show the solution. So x is equal to 1.3694. So this is quadrant number 1. And the second quadrant, just go 2 pi minus that value. So this is x is equal to 2 pi minus 1.3694. And I'm going to leave it like that. You can do the math yourself. You will get 4.9137. Okay, let's move to the opposite side of the page. Sine x is equal to negative 4 over 5. So again, you can use the unit circle, negative sign ratio. Remember quadrant number 3 and 4. But I like to see things on the graph. Okay, so my sine wave, like so, on that interval to 2 pi. Okay, and my intersection now is with negative 4 over 5. So that line just below negative 1, okay, let's say continues. So I have two roots on that interval pi to 2 pi. And again, no particular angle, the special angle is not being applied here. So use your calculator. And this is an interesting case where you use your calculator because x, when you go and show sine inverse of negative 4 over 5, punch in your numbers and you see the following. You see that x on your calculator shows negative 9, negative 0.92729. But you don't want to leave in terms of negative value. So what do? Just remember, so this would represents that negative portion in the fourth quadrant, so you go 2 pi minus that positive number, and that will give you 5.35589. So remember, you would just do quickly, that would be the negative value. So you go 2 pi plus that number. Okay, so that was the angle in the fourth quadrant. And by duplicating the same triangle here, you're looking at that angle. So you can do pi plus 0.927295. So let me do that. So I'm going to use my calculator. Pi plus 0.927295. Bingo. So the value for that angle is 4.06888. I'm going to round it up to 9. All right. So now we have two fantastic numbers that represent a solution for sine negative 4 over 5. And on that side, we have our solution for cosine ratio is equal to 1 over 5. 4 roots to that equation. Thank you very much for watching, and I see you next time. Bye-bye.